Hello guys, in this video we're going to talk about the worksheet chapter 11.1A level 2. So it's about the tangent to the circles. So it's actually talking about the tangent to the circle, which means a line touching the circle for once, touching at this point and leave the circle. So this tangent line is actually perpendicular to the radius, so that we have the right angle here. So that we call it as the tangent perpendicular to the radius. So that's the main theorem we need to know in this chapter. And another thing is that if we have a right angle, which means that AB is actually a tangent. So that's the converse. So it depends on which coming first. So if you have the tangent first, then which means that the radius is perpendicular to the tangent. If you're having a right angle here, which means that AB is actually the tangent. So let's do the first questions. So in this circle, we have angle x is this, angle y, and we have a tangent PAQ. So as the tangent PQ is actually perpendicular to the radius OA, so that we can say that the angle of OAQ is actually equal to 90 degrees by using the tangent is actually perpendicular to the radius. So that we have the x is equal to the 90 minus 65 degrees, giving you 25 degrees. And then the y is actually the angle at the center, and the x is angle at the circumference. They're looking at the same arc BC, so that we can say that y is equal to 2x is equal to 50 degrees. So by using the angle at the center twice angle at the circumference. So for question 1b, in this question we're going to find the x and y, isn't it? So as OB and OA are radii, so that x is actually equal to 43. We have x is equal to 43 degrees by using the base angles isosceles triangle. So for as we have the OAQ is 90 degrees, and we got the x is equal to 43, so y is actually equal to 90 minus 43, which is giving you 47 degrees by using the tangent is perpendicular to radius. So that's for question 1. So question 2a, we are determining that whether AB is the tangent or not. So first of all, as this is equal to 106, 104, and OP equal to OC as the radius, so which means that OPC equal to OCP, which means that this angle OPC is equal to 180 minus 104 divided by 2, giving you this is equal to 38 degrees. So this is 38. So now we have the angle OPB, which is equal to 38 plus 62, giving you 100 degrees, which is not equal to 90 degrees. So it's actually not the tangent. If you want the tangent, you need to use the converse tangent perpendicular to radius, isn't it? Which means that you need to get 90 degrees so that OP is perpendicular to AB, so that AB is the tangent. So let's try question B as well. So in this triangle, and then we can see whether AB is the tangent or not. So it depends on if it's a right angle. If this is a right angle, means that this OP squared plus PB squared is actually equal to the OB squared. So OB is actually equal to OC, where OC is the radius, so this is 10 as well. So we consider about the 10 plus 16 squared, which is equal to 26 squared, which is equal to 500. 26 squared giving you what? So 26 squared giving you 676. So we still consider about the 10 squared plus 24 squared. So we have 10 squared plus 24 squared, which is giving you the similar thing. Yes, it's equal to 676. So which means that the angle OPB is equal to 90 degrees. So that is actually, yes, that's the tangent. So let's now do question 3. So in the figure DA, we have DA as the tangent line, DC as the tangent line to A and C respectively. So now we have angle ABC is equal to 115. So they're asking you to find out this tangent angle ADC. So first of all, if you want to find out this angle, we're going to try to use something, and then actually we have the DA is the tangent, DC is the tangent, which means that the angle DAO is 90 degrees, angle DCO is 90 degrees. So now we have this angle, we want to find out the angle of ADC, so which means that if we understand the angle here, then we can find out this, right? So now we can say that the angle of the OAD is equal to 90 degrees by using the tangent is perpendicular to radius, and the angle of OCD is this one, so OCD is equal to 90 degrees as well, using the same reasons. So the reflex angle, this is the reflex angle. This reflex angle is watching to this arc, and this arc is watching by this angle ABC. So this is the angle at the center towards angle at the circumference, which is equal to double the angle of ABC by using angle at the center twice angle at the circumference. So it's actually equal to 2 times 115, and then give it this is equal to 230. So now we get this is equal to 230, which means that the angle of AOC, so that the angle of AOC is equal to 360 minus 230 by using the angle at that point. So giving you the angle of AOC is equal to 130. So that's the angle sum of the quadrilateral is equal to 360, isn't it? But four-side polygon, four-side one is actually equal to 2 triangles. So 2 side triangle sum is actually equal to 2 times 180, giving you 360. So we can just using the sum of quadrilateral, we have the angle of ADC is actually equal to 360 minus 90 minus 90 minus 130. So this one will give you 50 degrees. So that's for this question. Okay, so next page, so for question 4, then the figure P is a point here, and then we have the APB and OCB. APB, OCB are straight lines, and CP equal to CB, and angle CBP is equal to 30 degrees. Determine whether the AB is the tangent. So what we want is just this angle, is it 90 degrees or not? So first of all, we have the CP is equal to CB, which is given, so that the angle of CPB, the angle of CPB is equal to the angle of CBP, which is given as well. So we have angle of CPB equal to angle of CBP by using the base angles isosceles triangle, which is equal to 30 degrees. So now we have to say in the triangle of CBP, we have the angle of OCP, so that's the exterior angle, is equal to the angle of CBP plus the angle of CBP. So that's equal to 30 plus 30, giving you 60 degrees by using the theorem of exterior angles of the triangles. So now we can say that the angle of OPB here. So how can we find this? So now we have this is equal to 60, as this is the radii, so we have OC equal to OP, that's the radii, so that we have the angle of OPC is equal to 60 degrees as well. So that's the reason by using the base angles. Okay, so lastly we have the OPB is equal to OPC plus CPB. So it's equal to 60, or we can write it down, the name of the angles OPC plus angle of CPB, which is equal to 60 plus 30, giving you 90 degrees. So that's the, so now we can say that the AB is perpendicular to OP. So that's the converse of tangent perpendicular to radius. Okay, so now going to do question 5. So in the figure, we have PQ is a tangent to a circle. It's already saying that the tangent, so we can say the angle OPQ is actually 90 degrees. So now we have OQ cut a circle at B is here, and then R is a point on PQ such that PRQ this angle is equal to 68, so PAB is equal to 34. So how can we find out the angle of OQP? OQP, where is it? OQP is this one. So if you want to find out the angle of here by looking at this triangle, which means that we need to find out this. And to find out this angle is quite easy because this is the angle at the center, which is watching to this arc, and this arc is actually watching by this angle at the circumference. So we can first of all write it down as the PQ is the tangent, so that we can say the angle of OPQ is equal to 90 degrees by using the tangent perpendicular to the radius. And now we can say that the angle of POB, the angle at the center, this one, which is equal to the double of the angle at PAB, so which is equal to 2 times 34, giving you 68 degrees. And the reason for that is the angle at the center twice angle at the circumference. Okay, so now we get the angle here is equal to 68, so that we can say that the angle of OQP, the required angle, is equal to 180 minus 90 minus 68, giving the answer is 22 degrees. Okay, so by using the reason of angle sum of triangle. So now we need to determine whether this BR is the tangent, so which means we need to prove either this is equal to 90 degrees or not. So this is 90 degrees, means this is 90 degrees as well, as we have already got the angle of OQP. So we can say that the angle of the angle of QBR, so QBR is this one, QBR is actually equal to 180 degrees minus the angle of 68 degrees and minus the angle of the thing we find in question 1. So minus more 22 degrees is giving you 90 degrees. So that we can say the BR is perpendicular to OB, so that the BR is the tangent. That's the reason of converse tangent perpendicular to radius. So now for the last questions, we have CD is the tangent, and AB equal to BP. There's a reflex angle. How to find out the angle of BPD? BPD is here. So it's quite hard. There's nothing combine them, but we have this is radius. These two are the same. So probably we need to consider about the isosceles triangle, isn't it? So if you draw a straight line here, which means that with this reflex angle 220, this is actually equal to 140. So these two angles are the same. So that's the first thing. And then the second thing is this angle is equal to 110 because the angle at the center is actually twice angle at the circumference. So now we can get these two angles as well. So after we get these two angles, as this is 90 degrees, then we can actually get the required angle. So what can we say is, we can say the angle of AOP is equal to 360 minus 220, which is equal to 140 degrees by using the angle at a point. So now we can say that the OA is equal to OP, which is the radii, so that we can say that the angle of OAP equal to angle of OPA is equal to 180 minus 140 divided by 2, giving you 20 degrees. And the reason for that is the base angles. Isosceles triangle and together using the angle sum of triangle. I didn't mention that anymore. So now we have the angle of ABP. Angle of ABP is here. It's actually watching the same arc, watching by your this reflex angle AOP as well. So we can say that the angle of ABP is equal to 220 divided by 2, giving you 110 degrees. So that is using the angle at the center twice the angle at the circumference. Okay, so now we get this is 110, as we have AB is equal to BP, which is given, so that the angle of BAP is equal to the angle of BPA, which is going to be equal to 180 minus 110 divided by 2, giving you the answer is equal to 35 degrees. So as we have the OP is perpendicular to CD, so that the angle of OPD should be equal to 90 degrees. So that our required angle is this one, which is equal to this 20 degrees plus 35 degrees plus the required angle is equal to 90 degrees. So the required angle BPD is actually equal to 90 degrees minus the first angle, which is 20 by 20 degrees. The second angle is 35 degrees. So try to calculate it again. We have the angle, the required angle is equal to 35 degrees. Okay, so unless specified in this exam, even you jump the steps is fine. Okay, at least you give me how you do all of them. So if you have any questions, don't hesitate to ask me. Thank you.